When we talk about translating graphs, we're talking about shifting them left or right and or up and down. In this video, we're going to take a deep dive into seeing how and why this works the way it does. Let's say we have the most basic quadratic equation, y is equal to x squared. Its vertex lies at the origin. We can actually move the graph around anywhere through a combination of horizontal and vertical translations. Generally speaking, if we want to shift a graph a units to the right, we need to replace x in whatever function we have with x minus a. If we want to shift our graph a units to the left, then we replace x with x plus a. This may seem a bit confusing, but let's take a look at why this works. To do so, we need to dive deeper into how functions work. As a recap, a function is like a machine that takes inputs, which are x values, and runs it through an algorithm or a formula, which is just an equation that we have, and then it spits out an output, the y value. So let's apply this to our very basic quadratic equation. When we input minus 2, the machine takes in the input and the algorithm says to square whatever input is given, and so the function machine will spit out positive 4. If we put in minus 1, it will churn out positive 1. If we put in 0, it will churn out 0. If we put in positive 1, it will churn out positive 1. If we put in positive 2, it will churn out positive 4. Now we can see these points form our parabola. Now let's try to shift our graph 3 units to the right. To do this, we replace x with x minus 3 in our equation. This basically acts like a filter that mutates the numbers before it gets into the main function machine. So when we input 1, this goes through the filter where it subtracts 3 from our value. The result is that minus 2 now goes into the machine, where it gets squared and the output is 4. When we put in 2, the filter mutates that value into minus 1, and this value is then plugged into our machine where it's squared and comes out as positive 1. This happens for all of our values that we plug in, and the net effect is that we end up shifting the graph to the right by 3 units. Shifting the graph vertically is done in a really similar way. To shift a graph up by b units, we need to add b to the outside of our function. And if we want to shift it down by b units, we need to subtract it by b units. Going back to our basic quadratic, say we want to shift it down by 2 units. We can express this as y is equal to x squared minus 2. Instead of the filter being before the function machine, it's placed after. So whatever output we have, we subtract 2 from it. The result is shifting our graph down by 2 units. So to summarize, to shift a graph right and left by a units, we replace the x with x minus a or x plus a respectively, and to shift it up and down by b units, we add or subtract b units to our function respectively.